Coil may be, I'm having two interacting coils. Two interacting coils. These two are interacting. Current through this is I1. Current through this is I2. Now, let us see the orientation of the coil. Suppose I'm having a core on this, two coils are wound. The first coil is wound in such a way that so current I1 is flowing through this. Faraday's right-hand rule says, the four fingers indicates the direction of current and thumb indicates the direction of flux. Here, the direction of current is, this is, yes, this is in this way. It is going behind that core. That's why, that's why the direction of flux is the direction of flux upwards. Suppose if you wound on the other way, the flux is wound in the other way. That we'll see now. The flux is wound such a way that now the same current I is flowing means the flux is, the current direction is this way. That's why the direction of flux is downwards. The direction of flux is downwards. Let us consider here the flux. The second coil is wound like this. What is the direction of flux I2? Here it is downward. Here it is downward. The flux is downward. Here, let us found in the same way. Here, if you see the right-hand rule, here also it is downward. Here also the downward. Here, the flux 1-1 is because of I1. Part of flux links with the second coil. Here, the flux produced by current I2 is phi2. Part of the flux is linked with the first coil. The amount of flux produced phi1 links with the second coil is phi2. This indicates that I1. The flux produced by I1 but linked with the second coil is phi2. The same way, flux produced by second coil linked with the first coil is phi1. Therefore, if they are aiding means here the direction is downward. That's why it is in the same direction of flux of first coil. That's why these two are adding together, aiding. In that case, the mutual inductance M equal to, that is V equal to V1 equal to, how we will find V1? N1 5 N1 d phi11 by dt plus N1 d phi12 by dt. This can be also equal to L1 di1 by dt plus this is equal to M12 di2 by dt. This M is called mutual inductance. This is plus. Why plus? Because the fluxes are aiding each other. Here flux is aiding each other. Here, if you consider here, this flux comes this way, this flux comes this way. That is 511 is downward, 522 also downward. That's why they are opposing each other. In that case, V1 equal to, for the second diagram, this is second diagram, this is first diagram. The binding orientation of binding is opposite for first coil alone. Here V1 equal to L1 di1 by dt minus, because they are opposing each other, minus M12 di2 by dt. That's why the sign of M is, we have seen that M12 equal to M21 equal to M. So we can say mutual inductance M. So M have positive value or negative value depends upon the orientation. How to diagrammatically represent this? Here, it is aiding each other. That's why we can put a dot here. We can put the dot here. We can put a dot here and here. In this case, the I1 is entering through dot. Here I2 is entering through the dot. That's why aiding. Aiding. That's why M is positive. M is positive. Here, I is entering here through dot. Here I is entering. I is leaving the dot. Here, this is I2. I2 is leaving the dot. Here, in the first case, current is entering, the first coil current is entering the dot. The second coil also current is entering the dot. That's why aiding. Here, I1 is entering the dot. I2 is leaving the dot. I2 is leaving the dot. That's why opposing. Opposing, therefore, M is negative. M is negative in this case. Another two cases that we will see now. Instead of taking this way, here dot is here, current is leaving the dot here, I1. Here the dot is here. Here also current is leaving the dot. In that case also M is positive. M is positive. In both dots, current is leaving. Here in both dots, current is entering, therefore positive. Here in the dot, current is entering. Here in the dot, current is leaving. If it is in one dot, current is entering, another dot leaving means negative. Here we can say another diagram. In that case, here the current is leaving the dot. Current is leaving the dot. I1 is leaving the dot. Here, current is entering the dot. Again, this M is negative. M is negative. So, if current is in both coils, current is entering the dot means positive M. If in both coils, current is leaving the dot means M positive. In one coil, current is entering the dot. In another coil, current is leaving the dot means negative M. This is the convention used to represent the orientation of winding. How it opposes or aids, how it differs. The coil is wound this way, flux will be upward. If the coil is wound this way, the opposite way, flux is downward. That's why the orientation is represented by dot. Orientation is represented by dot. Now we'll see the relation between L1 and L2. Two coils are there. We know that M in the first coil equal to N1 512 divided by I2. M also equal to N2 521 divided by I1. Therefore, M square equal to N1 512 divided by I2 multiplied by N2 521 divided by I1. To get a relation, let us multiply by 511 divided by 511. 5122 divided by 522. Let us group such a way that we will get some relation. N1, N1, 511 divided by I1. So what and all gone? This I1 is gone, 511 gone, N1 gone. Now we can write N2, 522 divided by I2, I2 gone, N2 gone, 522 gone. What is the remaining? 512 is there. 512. This is flux from the second coil linked to first coil. Therefore, 522. Total flux produced in the second coil is 522, out of which 512 is linked with the first coil. Here, flux linked with the second coil is 521. What is the total flux produced in the first coil? 511. This ratio is called K. What is the total flux produced by second coil? 522. How much second coil flux linked with the first coil? Some part. The ratio is called K, coupling factor. Here, the first coil produces the total flux of 511, out of which 521 is linked with the second coil. This is called coupling coefficient. Coupling coefficient. Therefore, this can be, we know that this is equal to L1. This is equal to L2. This is equal to K. This is also K. Therefore, M square equal to L1, L2, K square, or M equal to K times square root of L1, L2. Only positive value, because all constants, parameters, that's why all positive. M equal to K times square root of L1, L2. That's all.